Hello, 6th graders. I hope you have been doing well. Today we are going to go over 1.4, which is all about prime factors and prime factorization. So before we get started, we're going to fill out our notes. So our topic and objective today is prime factorization. It's kind of a big word, factorization. One thing I noticed in that word is the word factor, which we talked about the other day. If you can remember what a factor is, that is awesome. I hope you remember because we will be using it today. So our learning target is I can write the prime factorization of a number using multiplication. So I can write the prime factorization. Sorry, that A looks kind of silly. Factorization of a number using multiplication. Alright, we are ready to start. So this, I hope, is a review to you, but before we really talk about prime factorization, we need to figure out what that word prime means. So we are going to talk about prime and composite numbers. So prime numbers are numbers that are only divisible by 1 and themselves. So this box right here is where you're going to fill in prime. Prime numbers are only divisible by 1 and themselves. So their only factors would be like 1 and 13. No other numbers times each other give us 13. Alright, and then composite numbers are numbers that are divisible by other numbers than 1 and themselves. So what that means is they have more than 2 factors. Okay, let's just remember what a factor is. If I have 2 times 3, which gives me 6, these two numbers, the 2 and the 3, are my factors. Alright, so what we are going to do is we are going to fill out this chart using these different colors. If it's prime, we're going to color it in red. If it's composite, we're going to color it in blue. And if it's neither, we're going to color it in yellow. Alright, so let's start with prime. So get out your red highlighter. I'm going to make these circles a little smaller. So here are the prime numbers. These are the numbers that you can only take 1 times that number and get that number. So for instance, 1 times 2 gives me 2. There's no other way I can take, no other numbers I can multiply together to give me 2. Another one is 3, and 5, and 7. So if I try to come up with other numbers, oh, I can make it darker, that's cool. If I try to come up with other numbers times together that give me 7, there's no way there are any others. The only numbers that are multiplied together to give me 7 are 1 and 7. Alright, so right now I'm going to list the rest of the prime numbers, and you are going to fill in your notes with all of these prime numbers. So 11 is prime, 13 is prime, 17 is prime, 19 is prime, 23 is prime, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So if you notice something, I noticed that a lot of the numbers that are composite end in 3, and a lot end in 7, a lot end in 9, and a lot end in 1. But not every number does. So it's important to know that just because it ends in a 7 doesn't mean it's automatically prime. Alright? So now we're going to do composite and neither. Okay? So, all the numbers that are composite, they are, let me change to a blue highlighter. All the numbers that are composite are numbers that have more than one numbers multiplied together to give us that. So for instance, 4 is composite because 2 times 2 gives me 4, and 1 times 4 gives me 4. Alright, so I would like you to take a second and highlight all the other numbers except 1. Alright? Go ahead and take this second now and highlight all the other numbers. Alright, now when you are done with that, there's one number that is not prime or composite. And that number is 1. Because the only numbers times each other that give us 1 are 1 times 1. And that doesn't work in the prime definition, and it definitely doesn't work in the composite definition. So that is just neither. Alright, so now we are going to start classifying numbers, determine whether if they are prime, composite, or neither, and then we're going to explain. So 12, if you look up in our chart, 12 we colored as composite. Oops, let me get a pencil, not a highlighter. So 12 we said was composite, and now we need to write why it's composite. Well, one way you could write it is you could say 1 times 12 is 12, and 2 times 6 is 12. That automatically proves that it is composite because it has more than just 1 in the number of factors. Alright? So now let's go to 2. 19. If you look at our chart, we colored it red, which tells us that it is prime. And the reason we know it's prime is because the only two numbers times each other that give us 19 are 1 and 19. I can think and sit here and think forever, but no other numbers will give me 19. Alright, let's move on to 3. 28. 28 we highlighted as composite because there are many numbers times each other that give us 28. So we've got 1 times 28, which gives us 28. And then we also have 4 times 7, which is 28 as well. So that one is composite. Now let's look at number 4, which is 13. If you look at 13, we highlighted it prime because the only numbers times each other that give us 13 are 1 and 13. So that number is prime. Alright. I would recommend doing E.3 on IXL because that's going to test how well you know prime and composite numbers. Alright, so now we are going to go over prime factorization. Alright, so prime factorization is expressing a composite number as a product of prime numbers. So on this blank here, you are going to write prime factorization. Factorization. Alright, here is what prime factorization is we are simply going to, step 1, create a multiplication problem. Multiplication problem. Oops, sorry. Alright, so we're going to think, what two numbers times each other give me 120? Well, I know that 120 is even, so I like to always do 2. 2 times what gives me 120? 2 times 60. Alright, so now if my numbers here that I write are composite, I'm going to repeat step 1. Okay, so if it is composite, repeat step 1. Alright, so I'm going to repeat step 1. 2 is prime, so I'm done with my 2. But 60, I can still take numbers times each other to give me 60. So I notice that 60 is even again, so I'm going to do 2 again. 2 times 30 gives me 60. But 30 is still composite, so I'm going to keep going. Oops, let me change colors, make it look cooler. 30 I notice is even as well, so I'm going to do 2 times. 2 times what gives me 30? 2 times 15. Now I know 2 is composite, 2 is prime, but 15 is still composite, so we're going to keep going. What 2 numbers times each other give me 15? Well, I know 3 times 5 gives me 15. And both of those numbers are prime, so I don't need to continue repeating step number 1. So once I'm done with that, my next step is if it is prime, I'm going to circle those numbers. Alright, so 2 was prime, this 2 was prime, this 2 was prime, this 3 was prime, and this 5 was prime. And now our last step is to write a multiplication problem. Multiplication is such a long word to spell. Write a multiplication problem. Alright, so my multiplication problem is simply going to be all these numbers that I highlighted. I like to put them in order. So I'm going to do 2 times 2 times 2 times 3 times 5, and I am all done. Alright, so let's look at a few examples. We've got 4 examples. So our first step is to create a multiplication problem. So to do that, I know that 25 times 3 gives me 75. I think of quarters. Alright, 3 is prime, so I'm going to circle it because I'm done with that one. But 25 is not prime. I know that 5 times 5 gives me 25. And 5 is I'm mixing up my words, I'm so sorry. 5 is prime, and 5 is prime. So now to write my multiplication problem, 3 times 5 gives me 75. Alright, now let's look at number 2. I'm going to write a multiplication problem. 9 times 10 gives me 90. Both of those numbers are composite. So what that means is I need to keep going. I know 3 times 3 gives me 9. And 3 is a prime number, so I'm going to circle that. And I know that 2 times 5 gives me 10. And both of those are prime as well. So to write my multiplication problem, 2 times 3 times 3 times 5 gives me 90. And if you wanted, you could double check that and see if it actually does. But we are going to move on to 185. Alright, so the first thing we're going to do is we're going to think of a multiplication problem. So I know that 185 is divisible by 5. And 5 times 37 gives me 185. I know 5 is prime, but I can't remember if 37 is prime. So what we could do is we could look at our chart that we colored. 37 is right here, and we said it was prime. So we can circle 37 and we're done. So our multiplication problem is 5 times 37. Alright, and our last one. I think these are fun. I hope you do as well. 200. I know 200 is even because it ends in a 0, which is even. So I'm going to take 2 times 100, which gives me 200. And I know that 2 is prime, but 100 is not. Alright, I know that 10 times 10 gives me 100. Alright, but both of those are composite, so I'm going to keep going. 5 times 2 gives me 10 there. 5 times 2 gives me 10 there. And those two numbers are all prime. So my multiplication problem is 2 times 2 times 2 times 5 times 5.